Hello everyone. So today we will be continuing with our chapter number 13, magnetic effects of electric current. And today we will see and we will learn the force on a current carrying conductor in a magnetic field. So till now we have learned that when a current passes through any conductor, the conductor acts like a magnet. Means the conductor acts or becomes like a magnet. So that the conductor which is acting like a magnet should also behave like a magnet when kept in a magnetic field. That means if we have a conductor which is wounded with copper wire or which is made as an electromagnet or solenoid, and when that conductor is given current, means when the solenoid is passed current through it, then the conductor will act like a magnet. And we know when we bring two same poles of a magnet close to each other, then these poles starts to move. That means, for example, if I have a magnet here, north, south, and I have another magnet, south, here, north. So what happens when two same poles of a magnet are close to each other, then the magnet starts to repel. They will start to move away from each other. Or if two different poles or unlike poles are in front of each other, then the magnets attract. That means a magnet can bring movement in another magnet by attraction or repulsion between the poles of the magnet. So we'll see what happens when we place a magnet or a conductor inside a magnetic field. Now just let us consider there is a piece of horseshoe magnet or curved U-shaped magnet. This is a, for example, U-shaped magnet. Here is our north, here is our south, for example. And then in between this magnet we have a piece of conductor which is wounded with wire. There is wire wrapped over the conductor and it is connected to a circuit. It is connected to a power source and this conductor is hanged here freely. It is hanged in this part. So what happens? Now what happens when the conductor is hanging freely between the poles of a magnet? This will simply act like a, if it is an iron, it will just simply act like a piece of iron. Means just imagine that this is not attracting, this piece of iron is not attracting to either south or north of the magnet, to any poles of the magnet. It is just hanging there freely without any disturbance. Now, when the circuit will be turned on, means when current will be passed through the circuit, the current will go through the solenoid or go through the windings of the conductor and will go back to the circuit. So when the current will flow through the conductor, this conductor will act like a magnet. And we know, we have studied that when current passes through any conductor, it induces some magnetic field within the conductor. If current is going in this direction, so it will induce some magnetic field in the conductor. That means that conductor will have its own north and a south pole, which will be induced by the which will be induced by the electric field. Now because this conductor becomes or acts like a magnet, now this conductor is placed between the magnetic field which is going from north to south, in this from here to here, from bottom to the top of the top direction. So this conductor will start to move. It will show some movement within the magnetic field. Like for example, if this is the magnet, just holding this book bent like this. So if this is a magnet and we place a conductor here. When the conductor is getting current, the conductor will start to move inside the magnet. It will move left and right or up and down. It will basically move within the magnetic field produced by itself and the magnetic field of the permanent magnet that is used. So this movement shows that whenever any conductor passing which is having electric current pass through it is placed between the magnetic field, the conductor experiences a force which makes the conductor move. Now this force is given by Fleming's left hand rule. Fleming's left hand rule. So according to this rule, we have to extend our three fingers, means the thumb, the forefinger and the middle finger of the left hand in such a way that they are mutually perpendicular to each other, like this. First here we extend, then we extend the middle finger like this. So you can see the direction or the extension. So this is the thumb, this is the middle finger, and this is the forefinger and this is our middle finger extended in this direction. Thumb is pointing upwards, and if we just consider the 3D model, this is like x-axis, this is y-axis, this is the z-axis, or this is pointing upwards. So this is how we have to extend. Now when we extend like this, these three fingers shows the direction of magnetic field, the direction of the electric current, and the force which makes the conductor move. So here the forefinger shows the direction of magnetic field, the middle finger shows the direction of electric current passing through the circuit, and the thumb shows the direction of force. So here if we consider, just look here, if magnetic field is going in this direction, north to south, and the electric field is going up, then holding our fingers like this is our magnetic field, this one, magnetic field. So magnetic field, electric current going up, magnetic field pointing this side, electric current going up, and the thumb which shows the force is pointing into the ball. Means the force which will make the conductor move will be in that direction, towards or through inside the ball. So this is how we can find out the force of any conductor placed in a magnetic field. This shows, forefinger shows magnetic field, middle finger shows the electric field, and thumb shows the direction of force. So if we consider like magnetic field going from this side to that side, this is magnetic field, and electric current, if it is going upward directions, this is electric current going up, then the force will be towards you or towards this side, towards the camera. So this is how we can understand. So here thumb, force means force on the conductor, then forefinger gives us magnetic field, direction of magnetic field, and our middle finger gives direction of electric current. So this is how we can understand the force of any conductor placed in a magnetic field. So just giving one more example. If I have a piece of magnet, if here is the north pole, here is the south pole, that means magnetic field is going from north to south. Or we can interchange this. We can take here north pole, we can take here south pole. And then a conductor is placed like this. And current is passing in this direction. This current is going from bottom to top. So in this case we want to know in which direction this conductor will start or will tend to move. So first we have to take our left hand, extend our fingers like this, and then magnetic field going this side, north to south. This thumb is the magnetic field. Then our middle finger shows the direction of current, which is going up, and similarly, accordingly, our force is towards out, means it's outwards, outside of the board or towards this side. This is how we can understand the force on a current carrying conductor placed in a magnetic field. Thank you.